This is a review of the Sunnytech hot air Stirling engine. This is model 4 with the blue LED generator all mounted to the board here. Inside the box you'll find the engine, which is already assembled. You'll find this little bottle here that has a wick and a cap. You have to put the wick through the metal cap and put it together, and that's about the only assembly you're going to have to do. It does come with an extra glass piston chamber and a glass cold air chamber. That's because they are fragile and they can be broken, so be very careful. In addition, you'll have a set of Allen wrenches to assemble and reassemble this with. You'll have a bottle that you can fill with fuel to more easily fill this one. You'll have an extra set of gaskets, a tube, and some pins that you'll need to attach the flywheels. In this demonstration, I'm using 95% denatured alcohol. The reason for that, it's a very clean burning fuel. There's no soot, so that way your glass cylinder doesn't get dirty. It also, because it's almost pure, it burns very hot and creates a very fast operation of the machine. This is available at your local hardware stores. This small Stirling engine is just an amazing toy. It's really a teaching tool or a conversation piece for your desk. It's a fully functional hot air engine where the flame heats the air in this cylinder and pushes this piston back, and as it does, this cylinder here pulls in cold air, and when it returns it pushes cold air through here to be heated and start the next cycle. This unit is made of aluminum, steel, brass, and glass with a wooden base. It's very nicely designed. Its craftsmanship and quality are really good. It would look good on somebody's desk, bookshelf, office, laboratory, and it'd be a great gift for the mechanical geek in your family or a friend. I love the fact that this engine here has a piston chamber that's glass, so you can actually see it moving back and forth. When I get ready to start this, I'm going to move this back so the piston's back here so it can heat this air in here. That way, after I let it heat for about 45 seconds, I'm going to give this a spin. It'll start the engine running, and it'll run very quickly. Having this glass chamber makes it more entertaining. You can see all the internal motions of the engine. This would work as well if it was made of metal. You just couldn't see the functionality. The unit will spin this flywheel here at speeds between 1,300 and 1,500 RPMs. As this cylinder moves back, it will actually move this piston over here, which will suck in cold air. When this cylinder is all the way back, cold air will flow through here, through this block, and into here to be heated for the next cycle. Even though this unit has rubber feet on the base, there's a place in here where you can set this bottle of fuel, and there's a spring on here to hold it in place. That's because you don't want this fuel falling off. It is a flammable liquid, and it just makes it more secure. This engine was invented in 1815 by Robert Stirling, who was a London pastor, so it was named after him. This happens to be what's called a dual-cylinder engine, and it has a single flywheel on the back. Actually, it has one here on the other side that has a belt on it down to this generator. This is what is called an external combustion engine. It's just an amazing engineering toy. It's a desk conversation model. This is what's called an alpha design of the engine using dual cylinders. It's a great example of how simple air can be used to create an engine type of motion. It's more efficient and less dangerous than a steam engine. When you want to stop the engine, you simply blow out this flame. You want to be careful. This denatured alcohol is such a clean fuel, it burns almost invisible. I'm going to turn the lights off so you can see the flame, but when you blow it out, make sure that a child or a student doesn't reach up and touch this because they can get burned. It does get very hot. I'm now going to put this fuel source in here. You can see it located. I'm going to light it and let it heat for about 40 seconds and then give the cylinder a spin. I'm going to turn the lights off so you can see the flame. After about 45 seconds to the minute, just give this a spin. You can see it running, and you can see the LEDs lighting up because of the generator. So you can see how this could be a functioning engine used to generate electricity. This engine, as you can see, is running very fast. When you want to stop it, you just blow out the flame, and it'll slowly run down as this chamber cools off. This is just a marvelous little engine. It's a great example to show children how ingenuity solved a problem. Just be careful. As I mentioned, this flame is very hot. The parts are hot when it's done running, so take care when demonstrating to children or students. Watching this thing run is so interesting, it's just fascinating. I like this little device. I'm going to rate it at 5 stars. I was impressed with its functionality, its design, and its quality. Just be careful. When it's running this fast, it can move and vibrate. You can see it moving on this table right now. You don't want it to walk off and spill this fluid onto the floor and start a fire. I was supplied a sample for test and evaluation. A review was not promised in exchange for the sample, but I stated that if I did review it, my review would be fair and honest. This review is done by JJ CEO.